Hello, I'm Bhairavsingh Ghorpade, and today we are gonna see the presentation for time series analysis of stock prices using ARIMA and portfolio optimization. Glossary has introduction, time series forecasting, decay Fuller test, ARIMA, dataset, implementation of time series forecasting using ARIMA, implementation of portfolio optimization, results, conclusion, and references. The investment is one of the most important decisions we take in our day-to-day life. Every investment decision is associated with some amount of risk and a hope of better return. Over the centuries, the investments are being done in various forms. In recent decades, investing in stock markets has been a popular option around the globe. Stock exchange gives us a common platform where we can invest our money, and a good investment gives great returns back to us. Time series analysis is a method of extracting meaningful and useful information from the time series. For stock data, trends, demands, seasonality, etc. are some key information that we extract. Also, time series forecasting is a powerful tool for predicting or forecasting future prices. Time series forecasting involves forecasting of stock prices based on historical data. A stationary time series is used for forecasting future values. Stationary series is a time series which has following three properties. First one is the mean of stationary series is always constant and it is not a function of time. Variance of series is always constant too, and this property is called as homoscedasticity. Covariance of two successive values should not be function of time either. The next topic is Dickey-Fuller test for stationarity. To determine whether the given series is a stationary or not, Dickey-Fuller test is performed on the series. In this test, we check for rho minus 1 parameter whether it's significantly different than 0 or not. Because a perfectly non-stationary series has rho's value equal to 1. Hence here the null hypothesis is rho is equal to 0. Now let's move to the ARIMA. So ARIMA is also called as autoregressive integrated moving average. ARIMA is one of the most commonly forecasting models of time series forecasting. Here in this project, we are using ARIMA for analyzing the trends of stocks. Mathematically, the ARIMA can be given as shown here. ARIMA model has three basic parameters, which is P, D and Q. P parameter is the number of lags or lagged observation included in the model. D parameter is the number of times the time series observations are differenced, and Q is the number of lagged errors. Now let's move on to the data set. The dataset that we are considering is stocks of top 5 companies of Apple, Adobe, Amazon Incorporation, Facebook and Twitter Incorporation. We are considering daily stock data from July 2014 to July 2019. This is obtained from Yahoo Finance website. The dataset has following attributes. It has opening value of stock, it has closing value of stock, it has daily high, daily low, close, adjusted close which gives adjusted closing value and volume of the stock. can see here we have plotted the trends of the given stocks. This is the Twitter. You can see on the upper left corner we have the Twitter data plotted. As you can see, the stock prices are abruptly declined in 2016 and it remained at the low till mid of 2017, and then again it started rising and it goes on rising till now. Also you can see there are some few spikes which gives sudden rise and sudden fall within a month or within a range of a month or so. Whereas for the Amazon, on the upper right corner you can see during the beginning of 2014 it was lesser than 500 points, but as the days passed on and it started rising and rising, and by the mid 2018 it was at the peak, and then it had a decline till beginning of 2019, and then again it's rising. Similarly for the Facebook, it's keep on rising and then it had a decline for half a year and then again it is rising. Also for the Apple, whereas in the case of Apple it is something different. Here you can see a rise, then a fall, and then a rise, and then a sudden fall in 2019 and a rise. For Adobe, it is rise and again fall for the 2019 beginning and then rise. In all these stocks we can see for Amazon, for Facebook, Apple and Adobe, there is a fall from mid 2018 to beginning of 2019, and then there is again rise. So basically our goal in this project is to determine the trend, whether it is gonna up or down in upcoming days, and based on that trend we are gonna decide whether we are gonna consider the stock for the portfolio or not. And based on the stocks that we are going to consider for our portfolio, we'll do portfolio optimization on the given stock. Now let's move on to the implementation of time series forecasting using ARIMA. All stock prices were forecasted using ARIMA. Here we are demonstrating the implementation of ARIMA on Apple data, and results of all the other 5 stocks are summarized later on. Given data is analyzed for looking for patterns or trends. We used R function called decompose for looking the seasonality in dataset. But we didn't find any seasonality in Apple stock price data, and also we didn't find any seasonality or any trend in rest of the 4 datasets as well. First to check the stationary property of the data, we used Dickey-Fuller test with confidence interval of 95%. The Dickey-Fuller test at the beginning gave us the result in which the Dickey-Fuller index was minus 2.2704 with lag order of 10 and p-value of 0.4638. The p-value of 0.648 is greater than 0.05, which is greater than 95%. That's the reason, is lesser than 95%. That's the reason we reject the null hypothesis, which implies that the given series is not stationary. Hence, we performed a diagnosis using R function and diff, which returns the number of differences required for converting the given non-stationary series to stationary series, and the result of this was 1. Hence we performed differences for the series once, and we again ran the Dickey-Fuller test on the differenced series, and we got the p-value 0.01, which is less than 0.05. Hence the differenced series is stationary. After we got the stationary series, we exploited the ACF and PACF graph. Here you can see the first lag itself is cutting the curve of ACF, and for the PACF around 10th it is cutting the curve. Hence we can say that the parameter P is equal to 10 and P is equal to 10 and Q is equal to 1. And since we have done differentiation, we have differenced the series for once, so we take D is equal to 1. Using this parameter, we performed modeling in ARIMA. The summary of the result is given below. From the summary, we can see that the model is performing better as we have lower RMSE and AIC value. We have RMSE value which is equal to 0.0154, which is pretty good, and AIC of -6877.8. This is the actual return versus forecasted returns. The actual return, actual logarithmic returns versus forecasted logarithmic returns. And here we can see that predicted prices are close to mean, and thus it does not explain the variance much. This is the prediction of future prices. So you can see that when we predicted at the beginning of 2019, where we kept the data of 2019 as hidden, and we predicted all the other values, and we got the trend which is increasing, which is pretty much similar but not accurate, because after few months the prices started declining and then again it is rising, and our trend shows that the prediction is rising. The trend of rising is shown in our prediction. So based on this, we can conclude that the stock for Apple is gonna rise in upcoming days, so we can consider the Apple for our portfolio. Similarly, we ran the ARIMA for all other 4 stocks as well, and here is the data we summarized. We got Dickey-Fuller value of -2.7064 for Adobe, and similarly -2.875 for Amazon, Facebook, and Twitter. We got -1.3568. P values of all these were significantly higher earlier. Twitter had a lot higher. So we performed the diagnosis, and where we got the number of differences as 1, and then we got the P values lesser than 0.5. These are the ARIMA results, and here we can see that AIC value and RMSE value both are pretty much smaller for all of the data, and also the trend is positive in all the data set. Hence we are including all the stocks for our stock portfolio optimization. After which we perform portfolio optimization by using R Studio, and this is the efficient frontier that we got, in which we optimized the given portfolio of 5 stock prices. This is the optimized weight plot, in which we can see that the Apple has 5%, Adobe has 5%, and so highest is given to the Amazon, which has 80%, and then Facebook 5% and Twitter 5%. This is the table for the weights and the stocks. As we discussed, Apple has weight of 0.05, Adobe has weight of 0.052, Facebook and Twitter too has 0.05 weight. Amazon, whereas given the highest weightage of 80%, that is 0.8, so Amazon is considered as the best among all the 5 for the investment. As the conclusion from this project, we draw the conclusion that above shown weights are the optimal for investment for the given stocks. We have taken 5 stocks into consideration, and we performed ARIMA to check the trend of the stocks. We found all 5 stocks have rising trend, and therefore we used all 5 stocks for portfolio optimization. Then we performed portfolio optimization and got the following weights of optimized portfolio, which we see, in which Amazon has 80% of weightage, and all the other, that is Apple, Facebook, Adobe, and Twitter, has 5% weightage. This was the presentation. This is the references that I used for this presentation and for this video for this project. Thank you so much.